Welcome GeoTrig. This is 10-3, Areas of Regular Polygons. The essential question is, how do you find the area of a regular polygon? Let's begin. So what is a regular polygon? Just to remind you, it's a polygon where all sides are equal and all interior angles are equal. So everything's kind of even around there. Some more vocab. We got a center of a polygon. It's like right there, kind of like the center of a circle. The radius of a regular polygon is distance from the center to one of the vertices here. So all these are radiuses. So in this shape, we got 6 of them. We got this other vocab word called apotheme. I think that's how you say it. It's like a possum, but with a th, a lisp. Anyways, perpendicular distance from center to side. So it's this distance here. It's basically halfway between a vertex, right? And you're going to form a right angle there. So that's the apotheme. All right, how do we find the area of a regular polygon? So I got a bunch of regular polygons right here. Square, pentagon, octagon, and a hexagon. Well, let's figure this out. Notice we got centers in each of these, and we got a radius, or radii, going from the center to each vertice. And we're forming triangles in each of these. Notice the square forms 4 triangles, pentagon forms 5 triangles, and so on. Well, we can find the area of each of these polygons. So each of those triangles is congruent. They have the same area, they'll have the same sides and same angles here. So to find the area of the whole polygon, we've got to find the area of each triangle. And the formula for the area of a triangle is 1/2 base times height. In the case of all these, our bases, like if I use this triangle here, are all going to be s. So the base is going to be s. So we've got 1/2 times s. Well, we also have the height. What is the height of each of these? Well, where was I going with this? Yeah. So the height is going to be the apotheme right here. So that's going to be your A. So instead of an H, it's going to be an A. And the thing is, each of these triangles is going to have this 1/2 times the side times the A. Well, since basically this side is going to be this, and plus you got another 1/2 times the side times your apotheme, and then 1/2 another side. So it's going to be the same thing. Well, guess what? The only thing that's going on here, all these sides add up to the total perimeter. So we can write this as another formula right here. The area of a regular polygon is half the product of the apotheme and the perimeter. So 1/2 times A, that distance from the center to the side, times the perimeter. That's basically adding those triangles all up. All right, let's do some examples. Pause the video. I got to find the measure of each labeled angle. I get angle 1, 2, and 3. So notice here that I have a pentagon right here, and the pentagon, one thing to find the measure of angle 1. Let's do that first. Measure of angle 1. If we go all around this dot, this is going to be 360 degrees, right? And basically each of these angles right here are going to be equivalent. One arc. So there's 5 of them, and the total around this has to be 360. So to find the measure of 81, I have to just take 360 and divide it by how many triangles I have here, 5. So if you do that, 360 goes in 72 times. So the measure of angle 1 is 72. All right. Now if you know angle 1 is 72, measure of angle 2, notice we're going to be cutting this in half. So 2 is going to equal 72 divided by 2. So that's going to equal 36. And now to find measure of angle 3, well, all the sides of a triangle have to add up, or the angles have to add up to 180. So it's going to be 90 plus 36 plus whatever that measure of angle 3. So 180 equals measure of angle 3. So I can subtract and add this adds up to 126. So 180 equals 126 plus the measure of angle 3. Subtract 126 from both sides, and then you get the measure of angle 3 is going to equal 54. Next one. Pause the video. Okay, the area of the regular decagon. Decagon, how many sides? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. So 10 sides. Now, the formula, the area equals 1/2 times the perimeter times the apotheme, which is going to be 112.3. Now, what's the perimeter here? Well, all these are 8, so it's going to be 8 times 10. It's going to be 80. So 1/2 times 80 times 12.3. So multiplying that out, half of 80 is going to be 40. 40 times 12.3. If I did that math, 12.3 times 40, multiply that out, 0, 2, carry a 1, 94 and decimal. So it's going to be, area is going to be 492. 492 what? It's going to be inches squared, or squared inches. That's it.